All right, so let's take a look at differential leveling. Differential leveling is one of the method of the leveling process. It is a process of measuring vertical distances from a known elevation point, which is usually the benchmark as a reference, to determine the elevations of an unknown point. An application of this one in construction is that for us to be able to determine the exact corners and elevations of the slabs, we will be transferring the elevations from a given known reference. In most cases, those are fire hydrant, um, sewer manholes as a reference or a benchmark. Another applications of differential leveling is to determine the cut and fill for say laying of pipelines in order to determine the invert elevations on the inside bottom part of the pipe and as well as the amount of backfilling into your pipes. So again, that is differential leveling. A lot of time, wanting to differentiate this type of leveling process is a closed loop, which means that you will run this particular method beginning at the benchmark and go into the directions of the unknown point that you are interested to determine the elevations, and then going back into the same elevations or the same reference point, which is the benchmark. So again, the differential leveling, it is usually conducted in a closed loop in order to check your values. All right, so there are several things that you need to do as you perform the differential leveling. Of course, you will be determining the backside, the foreside, and then later on, once you put them into your table, you will be calculating now the height of the instrument and of course the elevations at any given point. And at the end, you will be required to perform what they call as the page check or known as the arithmetic check, which is usually the elevation of the first point plus the sum of or the total of the backside minus the sum of the foreside reading must be equal to the elevations of the last point. If it is not, then you may have some errors somewhere else, or you may commit mistakes in reading the rod or in transferring the numbers. Okay, again, I am going to demonstrate to you in your lab how you're going to set up and how you're going to read the leveling rod, because that is very important before you go out and perform the leveling. All right, so let's take a look at some of the problems to where we will be able to apply. Of course, the data is already given, but in your case, you will be responsible in determining those numbers. All right, so using the profile shown, we're asked to complete a table for differential leveling. Determine the loop miss closures and compare with the allowable closures. And I'm going to show you that there is a means of declaring whether the data that you have gathered is acceptable or not, or whether those can be discarded and you may need to repeat your work. All right, so this is how you're going to perform, assuming that we have here benchmark A and you're interested in determining the elevations at point B. So you will be performing moving from left to right. However, one thing that I want to emphasize here, that the setting of the instrument, we call it the turning point, you need to observe balancing. What does that mean? That the locations of your benchmark and the next point, okay, turning point, they must have at least equal distance from the center of the instrument to your benchmark and to your next point. So how will you ensure that? Well, you could perform pacing in order to make sure that this instrument is halfway in between those two given points. So you will mark there You set up your instrument, level it, and you can begin to read now the instrument, the rod, leveling rod. So in this case here, the back side is 1.055 and the foresight is 1.451. Then once you have that, move that to the next one. Retain, put a marker here. You don't want to lose that because you will be using that again to determine the backside of this particular point, the TP1 or the turning point 1. Okay, and then locate your turning point 2. Make sure again that the instrument is halfway in between turning point 1 and turning point 2, and you repeat that until you'll be able to go back into the same elevations. So this is how it looks like. You begin at benchmark A. This is a plan view, which means that you're looking at from above. You're going in this direction until you reach the point where you will be interested in determining the elevations, and then go back in the other directions. This is what we call as the closed loop, as I mentioned a while ago, and each of these has a measurement. A good practice when you perform differential leveling is to draw the diagram. I want to really emphasize that because once you get back into to the room or to back to your office and you mix up those numbers, man, you don't want to repeat the entire process, which it may takes about 2 hours to 3 hours to perform, depending on how large the areas that you will be surveying. So if I were you, you may need to draw first the diagram so that you'll be able to see where you add, and you may need to indicate the reading as you move forward and then you move backward. So backside, foresight, backside, foresight, it will be much easier for you, okay, to identify, and it won't confuse you later on as you go back to your office. All right, so this is how it looks like once you transfer them into your field book or into your workbook. So they are being arranged. This is your benchmark A, TP1, TP2, benchmark at point B, TP3, TP4, and the benchmark at A. So you went back into your same reference point. So what you have here when you transfer on your benchmark A, you must have only a backside. There is no foreside. Okay, for your TP1, it must have both your backside and the foreside. So all of these black numbers here, those are corresponding to the data that you observe, and any of those red numbers here, those are the process number, or those are the calculated. So in this particular case, there is a given elevations for benchmark A. If there is no given known elevations of benchmark A, for the sake of determining the elevations or the difference in elevations between two given points, you can assume the value. Okay, in this particular case, let's just assume to be 100 meter. Alright, so once you plug in all those numbers or enter them into your table, you are now ready to perform the calculations. So the first thing is to calculate the height. The height of the instrument is equal to the elevations plus the backside. So in this case here, the elevation plus, that's why you have here plus, your backside is equal to the height of the instrument. And to determine the elevation of the first turning point, what you need to do is have the height of the instrument of the previous minus the foreside of that first turning point is equal to the elevations, and repeat the same process. So elevation plus your backside is equal to the height of the instrument. So in this case, 99.604 plus 0.927, that will give you 100.531. The height of the instrument minus the foreside, so 100.531 minus 1.295 is equal to 99.236. So go back here again to 99.236 plus the backside is equal to the height of the instrument. The height of the instrument minus your foreside is equal to your elevation. So it's just mathematical. It's not that complicated. You don't require to use differential calculus or any of those higher level mathematics, just an add and subtractions. All right, so the next thing, once you perform that, the next thing you have to do now is to add all your backside. This is what we call as the summation of the backside. And you have to do that as well into your foreside. And again, the last benchmark or the last given point, it must only has the foreside. So the first must have the backside. You don't have foreside. And the last point must have only the foreside and there is no backside. All right, so I provided here also the formulas on how to calculate them and a little bit of the first point calculations. And one thing that you need to perform is what we call as a page check or the arithmetic check in order to ensure that what you have calculated are all correct. As I mentioned a while ago, that the elevation of the first plus the sum of the backside minus the sum of the foreside must be equal to the last. In this particular case, 100 plus your backside plus minus your foreside must be equal to 100.07. That's your last one. So in this case here, your calculation is correct. But one thing that I want you to notice, because we started at the same point and we end at the same point, they should be the same number. It should be the same, right? 100 meter. However, you will notice that there is a difference between the two. And the difference between the two is what we call as the error. Okay, so in this particular case here, we have here the error, which is 0.007, or that is equivalent to about 7 mm. That is 0.007 meter, or that is equivalent to 7 mm. Now on your workbook, there is a corresponding requirement for accuracy that is depending on the Federal Geodetic Control Committee, to where they provided, or it depends on the surveyors of how much would be the accuracy for that particular surveyed information. So in this particular case, I took this from page 45. The formula to calculate is just C is equal to m squared of n. Okay, m is the degree or the order. It depends on how large is the area. In my case, I am going to use the third order, which is 2 to 20 acres of an area. So that's just a small areas, and of course, the larger the areas, the value of the m also decreases because it requires some more accuracy into it. So in this case, we have here 12, and the n is the number of setup. So we have here the number of setup is in between those given points. So we have here 1, 2, 3, 4, 5, 6. So we have 6 setup, and this will give you 29.44 mm. And we only have an error of 7 mm, which means that what we have observed, the values that we have here, those are acceptable based on the Federal Geodetic Control Committee. Okay, and that is a third order accuracy. All right, so that is the first problem that we have for differential leveling. Let's take a look at one more. Okay, so we have here a differential leveling node is shown below. Complete the table, perform the arithmetic check. So again, it is just the same. We've given here the elevation of your benchmark 1. Elevation plus the backside is equal to the height of the instrument. The height of the instrument minus the foreside is equal to your elevation here. So that is 125 plus 1.256 is equal to 126.256. 126.256 plus minus 1.886 is equal to 124.370. 124.370 plus your backside, that gives you the instrument here, 125.486 minus 1.527, and that will give you this. And you will notice all of these measurements are in distance, vertical distance, as mentioned in previous video. As a rule of thumb, when you're dealing with distances, we need to keep it the decimal places to 3, for areas 2, and for volume that is 1. So perform that until all the way to the end. In this particular illustration, the surveyor only did one directions. It didn't go back into the first elevation. That's why you will notice here it end up your benchmark 4. That is okay. If you are already an expert and you already use and expert in reading the rod, expert in leveling the instrument, then you could do one directions rather than creating a loop. But if you are just a newbies for differential leveling, it is a good practice for you to do the closed loop, for you to make sure that you're getting all the numbers correct. All right, so once you have all those calculations for the height of the instrument and the elevation, make sure to perform the page check. Remember that the elevation of the first plus the backside minus the foreside must be equal to the last elevation. So in this case, 125 plus 7.69 minus 13.097 must be equal to 119.593. If that is not the case, you need to go back and redo your calculation. So that is another examples for differential leveling. All right, so another one here, a differential leveling loop. So this one here, it went back to the same elevation. This will be pretty much the same as the lab exercises that you'll be doing. I might be asking you to determine the elevations of a given tree, and you will be referencing that to a given excuse me, leveling given elevations on a manhole or probably a fire hydrant to transfer the given elevation. So again, this is a closed loop beginning at benchmark 3, and you are interested in determining the elevations at benchmark X. Alright, so we have given here all the information, but in your case, don't do this one. I advise you to draw the diagram and put in those numbers as you move on into your setups. So backside, that is the readings on the tree. So we have here 3.18 for this one, and then we have 4.76 for your TP1, and we have a backside of 2.44, and then move around. All right, and then put that into your table again. So in this particular case, we are asked to adjust as well too, because you will be doing that in your lab exercise. All right, so plug in all the data that you have. Remember, for the first point, there is no foreside. The last point, there is no backside. You have your foreside. All right, so perform your calculation now. Elevation plus your backside equals to the height of the instrument. The height of the instrument minus your foreside is equal to the elevations. And then you have to perform your page check. So in this case, we have here 323.48 plus 14.6 minus 14.52, and that gives you 323.56. You base on your page check, your calculations is correct. However, you will notice that for this surveys, you went back into the same reference point. Then it is it must have the same elevation of the first and at the last one. However, in this case here, we have 323 and we have 0.48 and we have 323.56. So in that case, there is a given error. So to determine the error, you just need to calculate the difference between the two. 323.56 minus 323.48, and that will give you 0.08. Since the elevation of the last point is greater than the elevation of the first, the error should be deducted. So the other way around, if the elevation of the last point is lower than the elevation of the first, then you are going to add. Okay. Now, to apply the adjustment, you just need to have your error, which is 0.08 divided by 4, which means that you will be applying 0.02 per given setup. However, as you do the setup, it must be cumulative. That's why if you are moving into the second point, you have to double the error. As you move into the third, you have to triple the errors. And that's what we have here in this particular columns, the adjusted elevation. So this is the 323.48. We are not going to adjust that because that's a given. Okay, so we have here the elevation at TP1. We are going to adjust that up minus the error. Okay, this should be 0.02 times 1 must be equal to 321. So again, take note of that. I made a typo here. That should be 0.02. And then 321.29 minus 0.02 times 2. That's the number of setup, or the second setup. The third, you have to triple that. And at the fourth, you have to triple that. And by the time that you get into the last one, this value here, okay, this arrow here, this one here should be all the way here, okay? The given value here and the last one should be equal, okay? Again, the first one, once you perform the adjustment, you have to make sure that the last one and the first one are now equal. All right, so that is how you are going to adjust that. So you will do that on your lab exercise. All right. Let's take a look at some applications in the constructions. Laying out of a pipe for civil works. So if you are the project engineer of a given project and you've given here the following information, you're asked to estimate the amount of cut at every given station as well as the layout elevation. The stake elevation at manhole 3, so there is a given manhole, this one here, is 429.27. That is the stake elevation at the ground surface. This elevation that you have given here, that is the inside elevations of the pipe. Okay, so there is a given slope of 1.2%. That is approximately about 1.2 feet per a given 100 foot of horizontal distance. And we are going to determine, we're going to stake out at a distance of 0 plus 50 from manhole 3, and then 1 plus 0, 0, 1 plus 50, 2 plus 0, 0, 2 plus 50. While in surveying, this is what we call as stationing. What does that mean, this plus here? The plus sign separate the full length and the partial length of the steel tape. The full length, usually we use a 100 foot steel tape. So if you have measured 100 foot, that is 1 plus 0, 0. Okay, so if you go beyond that, you have to separate the partial length. Okay, so again, the full length separated by the plus sign. That is what we use in surveying. All right, so we are asked to determine the stake elevation at every given point here. Okay, all right, so to do that, we need to calculate the difference in elevations per station. The difference in elevation is based on the slope. And what is the slope that we have? That is 1.2, or that is 1.2 feet per 100 feet. So the elevation, difference in elevation of the first one is 0.6 feet. 0.012 times 100, because that's 1.2 divided by 100, so that is 0.012. So 50, that is a first, because from this point to that point, the distance is 50 feet. Okay. All right. So the next one is 100, because that is from this point. That is 1 plus 0, 0. That's 100. And this is our reference. So 100 minus 0, that's 100. So you do the same thing, 150, until you reach that distance of 300 feet. And each of these value here at every given distance, this is the difference in elevation in each of those. Okay. So again, all of these values are the elevations on this invert here. And to determine the elevations on the invert of this pipe at 0 plus 50, we did this calculation here. Okay. The invert elevation at 0 plus 50 is 420. So we have here 420.86 plus whatever this one here, because you're going up. If this diagram here is going down, then you have to subtract them. But since we are referencing here on this manhole tree, we're going up, so the elevation should go up. So that's the reason why you will notice that this value here are going up. Okay. Alright, so calculating cut is the difference between the stake elevation and the invert elevation. If concrete pipe thickness is given, the thickness must be added to the cut depth. So how do we do that? So there is a stake elevation. So if there is a backside, these are given. Okay, so all of these values here, those are the given, and you did this based on the differential leveling method. You calculated the backside, and we have those individual force side in each of those stationing until you reach your manhole tree. All right, so this will be this is given. These are the values that you will be determining in the field. Okay, the force side and the back side, and you need to calculate this one. How do you calculate this? Is this value plus the back side equals to the height. The height minus either the force side or the intermediate. This is IFS, intermediate force side. So you subtract this value minus this is equal to this value here. This value minus this equals this. 423.52 minus 4.65 equals 428.87. 423.52 minus 445, 429.07. 423.52 minus 410, that gives you this, until you'll be able to get all the way to the end. It is 423.52 minus 3.75, and that will give you the stake elevation. So when we say stake elevation, that is at the ground surface. And this invert elevation, that's the one that you calculated previously here. Okay, just plug in those numbers here. Okay, and then just subtract these two values here, and that will be the amount of cut. Now if you have the thickness and the diameter of the pipe, you can also determine the amount of backfill by subtracting also the thickness and the diameter of the pipe. So take note of that. This is the cut all the way to the inside lower face or lower inside of the pipe. If you have the diameter and the thickness, you need to subtract that from here to determine the amount of the backfill. So again, to determine the amount of cut, you just need to subtract the stake elevation and the invert elevation. This value here are the one that you calculated from this one here. Okay, and this stake elevation is the same way that you calculate in differential leveling. So these are the values that you will be determining, and you just need to perform the calculations. Okay, all right, so that is the application for the differential leveling. So differential leveling, it is a method of determining vertical control, vertical elevations, or the elevations of any given point on the ground surface, and it is also being used to determine the amount of cut or even fill. The differential leveling, in order to check your data, it is advised that you may need to do a closed loop, especially if you are just a newbie in using differential leveling method. All right, till then.